right, welcome in. I'm going to go ahead and go over these problems with giving an explanation for the conceptual problems as well as the showing the math steps behind the mathematical problems. So let's get started. In order for that to work, the direction needs to be applied in parallel or the same direction as the movement, which you call displacement. So force and the displacement needs to be in the same direction. Number two, the variable for power is P. The units for power is W for watts. The variable for work is W, and the units for work is J for joules. If you're holding an object stationary, is there work being done? No. The reason is because the object is not having any kind of displacement. If you lift an object from the ground, are you doing any work? Yes. You had a vertical force that allowed you to move the object upwards, and the force was parallel in the same direction as the movement of the object. If you're walking across the room and carrying your laptop, or any item for that matter, are you doing any work? The answer to that is no, because even though the movement of the object and you are both horizontal, you are applying a vertical force, so they're not parallel or in the same direction. You're applying a vertical force to hold the object, whereas the object and you are both moving horizontally. If you drop an object and it falls to the ground, did you do any work, meaning you personally? The answer to that is no, because you didn't apply any force for it to fall. You and a friend are given identical sized lawns to mow. You completed it faster than your friend. Who did more work, assuming you both had the same mass? Well, work is force times distance. So if you have the same mass, you're doing the same amount of distance because it's the same size lawn. So you both did the same amount of work. You and a friend are given identical size lawns to mow. You completed faster than your friend. Who had the greatest power, assuming you both had the same mass? So power is work divided by time. You both did the same amount of work. However, you completed it faster, which means that if we think about work being a value of 100 and your time was 10 seconds, then your value is 10. If we say your work for your friend was also 100, but did it slower at 20 seconds, 100 divided by 20 is 5. So you had the greater power because you took less time. All right, let's move on to the math problems. If 72 joules were necessary to move a crate with 8 newtons of force applied, how far was the crate moved? So we're looking for a displacement, or D equals question mark. And they don't mention anything here, but from the units we can tell that that's our work. So that's 72 joules. And a force of 8 newtons. So F is equal to 8 newtons. The equation is going to be W is equal to F times D. Substitute the values of 72 is equal to 8 times D. Divide by 8 on both sides. And we get our displacement as 9 meters. Number 10, a person weighing 1,200 newtons gets on an elevator. The elevator lifts the person 17 meters in 15 seconds. How much power was used? All right, so we're looking for power with the units of watts. Person's weighing 1,200 newtons. So remember, that's our F normal, which is basically our F. So our force is 1,200 newtons. And we have a displacement of 17 meters in a time frame of 15 seconds. So our equation is going to be P is equal to W divided by T. Of course, we don't have work, but we do have force and distance. So P is equal to F times D divided by T. Place our values. 1,200 times 17 divided by 15. And we get our power as 1,360 watts. Number 11, if 240 joules are needed to move a crate with a distance of 400 centimeters, what's the weight of the crate? So again, like we said here, weight is our Fn, so you're really looking for the F or the force. So F is our unknown. We've got 240 joules, no mention of work, but the joules is our hint for that is our work. So W is 240. And finally, we've got a distance of 400 centimeters. Now, it's 400 centimeters, which means you've got to convert to meters. So our decimal, as it stands right now, is here. And we got to go back 2 spots, or divide by 100. So it's going to be our actual displacement is 4 meters. And that's what we're going to use as far as our displacement is concerned. Make sure that you are in meters. So W is equal to FD. We've got 240 for our work. Our force is unknown, and our distance was 4 meters. So we're going to go ahead and divide by 4 on both sides, and we get our force as 60 newtons. Number 12, if a group of workers apply a force of 800 newtons to move a crate 30 meters, what amount of work will they have accomplished? So work is what we're solving for, the units of joules. Our force was 800 newtons, and our displacement was 30 meters. Same formula, W equals FD, 800 times 30 is going to give us a work value of 24,000 joules. When you're doing multiple choice, make sure to select the right amount of zeros and punch in the right amount of zeros as well in your calculators. Number 13, you carry a 3 kilogram sack of potatoes across the store for 2.5 minutes. You wait in line, holding it for 30 seconds before you get tired and drop it. You then lift the sack of potatoes upwards for 120 centimeters and place it on a counter. How much work did you do at the store? Well, you exerted a lot of energy and you put a lot of force, but realistically, how much work did you do? So W is what we're solving for, the units of joules. Now, there's no mention of force here, so if we don't have F, so we don't have it, which means we're going to get mad. So we need our mass, acceleration, and our displacement. So mass of the potato sack was 3 kg. Acceleration due to gravity is negative 9.8, but remember you're applying an upwards force to support the weight of that. So it's positive 9.8 meters per second for us. And now the displacement. Remember that the only time that we have work is when you have applied a force parallel or in the same direction as the displacement. So even though you're carrying it across the store and you're holding it in line, that's not any work because the force is upwards and the movement is either stationary or across horizontally, depending on which sentence you're reading. So the only time you actually do any work is when you apply an upwards force to lift it up from ground and the object moves up. So our displacement is 120 centimeters, but then again, you got to convert it to meters. So it's actually 1.2 meters. Go back to our equation. W equals FD. Work gets broken down to the M times A times D. So work is 3 for mass, acceleration is 9.8, and our distance is 1.2 meters. Plug all that in, and we get 35.28 joules. All right, moving on to number 14. If a man with a mass of 88 kilograms puts on a 5 kilogram backpack and climbs a ladder having a displacement of 30 meters in 15 seconds, how much power did he use? So P is equal to question mark in watts, and we've got a couple of different masses. So our M1 is 88 for the man. Our M2 is our backpack at 5 kg. So when the man puts on the backpack, now his mass is a combined amount of the two. So our M total, or MT, is the sum of these two. So it's actually 93 kilograms, and that's the mass that we're going to use. Now, there's no mention of force, so no force means we get mad. So you got to put an acceleration due to gravity, 9.8 meters per second squared. Distance is equal to 30 meters, and our time was equal to 15 seconds. So like I said, we're going to be using this mass over here. Our equation is going to be P is equal to work divided by time. course, we don't have work listed, so we got P gets broken down into F times D divided by T, and ultimately the F gets broken down to M times A. So it's M times A times D divided by T. Go ahead and substitute our values, and we get a mass of 93 kilograms times our acceleration of 9.8 times our displacement of 30. And I'm going to go ahead and put double parentheses because if you're punching in the calculator, you want to make sure that's done first before it gets divided by 15. And our power is equal to 1,822.8 watts. All right, number 15. If 45 watts is produced in 9 seconds, how much work is done? So W is equal to question mark with joules. 45W is watts, so that's our power. And our time is equal to 9 seconds. So P is equal to W divided by T. Substitute our values. 45 is equal to an unknown work value. That's just what we're solving for, divided by our time. So it's 9 seconds. So in order to get W on its own, we need to multiply by 9 on both sides. So W is equal to 9 times 45. So our work is 405 joules. Number 10, how much time is needed to produce 360 joules if 40 watts is used? So T is equal to question mark. There's no mention of power or work. We just got to figure that out from our units. So 360 joules is our work. And watts is going to be our power. So P is equal to 40 watts. Our equation is going to be P is equal to W divided by T. And we're solving for this bottom one. So anytime we got an equation like this, and we're solving for the bottom, these two flip-flop ultimately, and it becomes T is equal to W divided by P. So we're substituting our values, and it's 360 divided by 40. So our time was 9 seconds. And finally, number 17. A set of pulleys lifts a 50-kilogram box 3 meters in 5 seconds. How much power was used? So P is unknown with the units of watts. And, of course, power is going to need work, but there's no work mentioned. There's going to be a force. There's no force. So we're going to have to go get mad. So our mass is 50 kg. Our acceleration is going to be 9.8 meters per second squared. And our displacement is 3 meters. And finally, our time is in 5 seconds. Okay, so our equations, P is equal to W divided by T. Ultimately, work gets broken down into mad divided by time. And now we'll go ahead and replace our values. We had a mass of 50, our acceleration was 9.8, and our distance was 3 meters. Again, you want to make sure these are all multiplied out first before dividing by your time, which was 5 seconds. So our power is equal to 294 joules. Okay, I hope this was helpful. Have a wonderful day.